Okay, so what we're going to do now is consider our probability outcomes as a particular variable. Okay, so it is a random variable, so the probability that something occurs and how often something occurs are both random variables, all right? So there's two types of random variables. We have a discrete random variable, which is just whole values, so discrete data, 1, 2, 3, 4, counting. Or we have continuous random variables, which typically are values that can take on a quantity within an interval. So it might be a height or a weight, a time. You have 2.3 seconds or 22.4 kilos, that kind of thing, 182.3 centimeters. So in terms of whether something is discrete or random, so the discrete variables here would be the number that you roll on a die. It's a whole number. The number of coin tosses until a tail, so it's got to be a whole number of coin tosses. The weight of a person, not so much. It could be decimal. Time taken to run 100, again, a decimal. The color of a shirt worn by Mr. Smith, okay, again, it's a discrete data because it's a particular, okay? Now, we can represent this data in a couple of ways. We could represent it as a table, as a graph, or as a function. So let's consider this particular example here. So the probability distribution of a random variable could be anything. Okay, this is a probability of something happening. So let's consider if x is equal to 2, that means the probability that x is equal to 2, we just substituted into that rule, 16 over 15 times 2, which is 16 over 30. Okay, probability that x is equal to 4, we get 16 over 15 times 4, which is 16 over, what's that, 60. X is equal to 8, I should say. We get it's equal to 16 over 15 times 8, which is 16 over 120. Finally, if x is equal to 16, I get 16 over 15 times 16, which is 240. So let's put everything in terms of 240, 16 on 240 there. That one is 32 on 240, times by 4, so we get 64 on 240, times by 8, 8, 16, 48, 128 on 240. So that's the probability of each of those different things occurring. If we've done it right, the probability should add to 240, or add to 1, I should say. So 32, 64, 6 plus 16 is, what's that, 112, plus 128 is 240, so it is 240 over 240. So that makes it a probability distribution because all the probabilities add to 1. And what this table is saying is the probability of getting an 8 in whatever we're doing is 32 on 240. Okay, so there's a table and a rule there that represents my data. Then graph this particular this function, 16 on 15x. So really to graph it, what is it? 16 over 15. I guess all we're doing is we might have 2, 4, 8, 16, and I'll just put values. Look, I'm not going to, it's actually a dot. It's not a line joining it. Yeah. In fact, it's the opposite, isn't it? Hang on. The higher the number, the less likely. So it might be 2 here. And we could, in fact, sketch the line X. So it does look, if I was to do it, it might look a little bit like that. Pause. So the actual graph is a 1 on X graph, isn't it? So it looks a little bit like that. And all we would do is actually just have those points drawn in. Yeah, so the red line doesn't exist. So I'll rub it out just to clarify. Red line doesn't exist. So they're the points. So that's the graph, if you like, of that particular probability function. All right, and again, it's only to find the probability of x is between 0 and 1, and the sum of the probabilities is 1. All right. So which of the following are not probability functions? Let's have a look. 0.2, 0.3, so they all add to 1. That's fine. You can have negative values for x. So this might be the profit in a game. 5 might be a $5 profit. A -1 means you might lose $1, okay? 1/3 plus 1/3 plus 1/3 all adds to 1, so they're fine. -0.2, 0.4, 0.8, they all add to 1, but we can't have a negative probability. So this is not a probability density function, okay, or distribution. What else we got here? All right, towards the end. So we've got an example. A spinner numbered 1 to 8 is spun, and each outcome is equally likely. Find the probability of. First, find the probability distribution. All right. So in this case, clearly we've got our probability spinner, 8 different sections. So the probability of any one of them is 1/8. Now to find these probabilities, we might need to do different things to fill in our table, but there's my probability distribution, okay? What's the probability that x is greater than or equal to 5? Greater than or equal to 5 is these ones here, and that's simply equal to 4 lots of 8. And what does this say? The probability that x is equal to 6 given x is greater than or equal to 5. So that's a conditional statement. So the probability of A given B is equal to the probability of being a 6 and greater than or equal to 5 over the probability that x is greater than or equal to 5. So how many of those numbers are equal to 6 and greater than or equal to 5? Well, there's only one of them. So the probability of getting any one of those is 1/8. And what's the probability of getting a number greater than or equal to 5? Which is equal to 4/8. So 1/8 times 8 over 4 is equal to 1/4. Okay, so that rule works every time, any time. A given B, A intersection B over the probability of B. All right. A biased coin such that the probability of head is equal to 0.8. Find the probability to distribute X number of times if we toss the coin twice. So first things first, let's work out my 2 head coin tosses, head, tail, head, tail, head, tail. And the probability of a head is 0.8, so that's 0.2, 0.8, 0.2, 0.8, 0.2. So that's 0.64, 0.16 as we multiply along. I've got it right. 0.32, 0.64 is 0.96. They all add to 1. So that's my table, right? So now, sorry, that's my tree diagram. The probability distribution looks like this. There's X, and if I toss a coin, I can have 0 successes, 1 success, 2 successes. In here is the probability of X. So what's the probability of 0 heads? That's the same as 2 tails, which is 0.04. The probability of 1 head, well, it could be head, tail, or tail, head, so it's those 2 outcomes. 0.32. The probability of 2 heads is a head, head, 0.64. So you can see how really my probability distribution is just a way of representing maybe all the probabilities that we've been working out previously. All right, spinner labeled 1 to 4. This is the sample space. So let's just make it a bit bigger. Sample space is 1, 2, 3, 4. Find the probability of X, the sum of the 2 numbers. So we're going to add the 2 numbers. So sometimes, again, what are the different outcomes? So since I want to add the numbers, I'm going to do a little table. And 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5. 2 plus 1 is 3, 4, 5, 6. 3 and 1 is 4, 5, 6, 7, and 4 plus 1 is 5, 6, 7, 8. So in reality, I'm spinning the spinner twice, so I'll get two numbers. But what I'm recording in my experiment is what those two numbers add to, all right? So they're in red, they're the outcomes. So now my probability distribution looks like, well, what are the possibilities? I can get as low as 2 and as high as 8. 2, 3, 4, 5, 6, 7, 8. So that's X. The probability of getting X is, how many 2s are there? Well, there's only one. And there's 16 possibilities, so 1/16. How many 3s? There's 2. How many 4s? There's 3. So there's 3 ways I can get a 4. Thinking about, I can get a 1 then a 3 then a 1, or a 2 and a 2. So they're my 3 possibilities. Of getting a 5, there's 4 of them. And then we make our way back down. Okay, so if I've done it right, 1 plus 2 plus 3 is 6, plus 4 is 10. It adds up to 16 on 16, which is 1. So there's my probability distribution. They all add up to 1. Now I use that to work out whatever problems I've got. C says the probability of A given B. So the probability of being greater than or equal to 4 given it's less than or equal to 6 is the probability of greater than or equal to 4 and less than or equal to 6 over probability of X is less than or equal to 6. So let's look at our table. We'll work with green. What's the probability of it being greater than 4 and less than or equal to 6? So greater than or equal to 4, less than or equal to 6 are those three numbers, 4, 5, or 6. And what's the probability of getting a 4, a 5, or a 6? 3/16 plus 4/16 plus 3/16, 10/16. What's the probability of getting a number less than or equal to 6? It's all of these. So it's those 10 plus another 3. So that's 13/16. So divide by fractions, flip it upside down and multiply. 16 on 13, which is equal to 10/13. Okay? Off you go.